this video, we'll be covering 7.5, apply the tangent ratio. So let's recall exactly what is a trigonomic ratio. So it is a ratio of the lengths of two sides in a right triangle. Now, the reason why I'm emphasizing the word right is this only works in a right triangle. Now, a very common trigonomic ratio mnemonic to help us is something called SOH, CAH, TOA. So remember that we talked about yesterday, we will have a reference angle, theta, and we will have an adjacent side and an opposite side, and then the hypotenuse. If that reference angle changes, then this is the opposite side, this is the adjacent side, this is the hypotenuse. So we have a little saying called SOH, CAH, TOA. SOH is the sine ratio, where you do opposite over hypotenuse. So there's the SOH. Cosine is CAH. Cosine theta is the adjacent leg over the hypotenuse. And then tangent is opposite over adjacent. So TOA, tangent opposite over adjacent leg. And today we're going to focus on the TOA part. So we are going to focus on tangent. So let's look here and let's just write down SOH, that is sine, CAH, that is cosine, and then tangent, which is opposite over adjacent. And that is the one that we are going to focus on today. We'll do sine and cosine in later lessons, but for right now we need to just focus on tangent. So it says let triangle ABC, so let's label this triangle ABC, be a right triangle with an acute angle A. Here is A. The tangent of angle A, written as tan A, is defined as follows. So if we're doing this in regards to A, this here is the opposite leg of the right triangle, and this is the adjacent leg of the right triangle. Now for tangent, we do not utilize the hypotenuse. We only do the opposite leg over the adjacent leg. And remember that a trigonomic ratio is a ratio, so we make a fraction. So tangent A, angle A, is equal to the length of the leg opposite of A over the length of the leg adjacent to A. So if we were labeling this with correct geometric terms and symbols, we would say the length of BC divided by the length of AB. That is the tangent ratio defined. So now, using that definition, we're going to travel to the next section. It says find tangent ratios. Find tangent S and tangent R. Write each answer as a fraction and as a decimal rounded to 4 places. Now, focusing on the 4 decimal places. This is very important. Unless you're told otherwise, you are always going to round the trigonomic ratios to the 10,000th place, and you are going to round lengths of the legs to the 10th place. So this is going to be the rule that we always use, and I will always try to remind you of this rule. But if I don't, you have to follow this guideline. So we are given triangle STR. It is a right triangle, and it wants us to do tangent S. So S is going to be the reference angle first. So we are going to go opposite of S and then adjacent to S. So opposite of S is the segment TR. Adjacent is segment ST. So TR in the diagram is 60, and ST in the diagram is 25. The directions tell us to do a fraction and a decimal. If I divide this down by 5, I get the reduced fraction of 12 over 5. Now, if I do this as a decimal, of course, I would take my calculator and I would simply say 12 divided by 5. Now, it came out to be 2.4, but it tells us to round to 4 decimal places. Therefore, I will say 2.4000 and get the 10,000th place indicated. Now, looking at R, we are going to now switch reference angles. So now we're going to do this angle. Now, opposite of R is now going to be ST. Adjacent to R is going to be TR. So now ST is 25, and then TR is 60. Divide this one down by 5, and this time we get 5/12. Now notice that these are reciprocals. When I calculate this on the calculator, 5 divided by 12, I get this. Now remember, we have to do a fraction and then the 10,000th place. So we are going to say approximately. Notice how this one says equals, this one says approximately, because we are truly going to follow rounding rules. So this is 416.7. So it's these little details that I need you to pay attention to. Equal sign, approximately. Now, that is an example of how you would write the trig ratios. Notice that we are doing ratios here. So now, number 2, it says find tangent J and tangent K. Now, it does not say anything about a fraction. It just says round to 4 decimal places. So for this one, you would start out with tangent J. Tangent J. And remember TOA. Tangent is opposite over adjacent. So opposite of J is 24. Adjacent to J is 32. We do not use 40 with tangent because it is a hypotenuse. So now, 24 divided by 32. If it did tell us to do a fraction, we would go math fraction and get 3/4. So for this one, it's equal to 3/4. And this one would be equal to 0.7500. Now, switching to tangent K, we are now to this reference angle, opposite over adjacent, so 32 over 24. Reduce that down, that is going to be 4/3. Now, this is equal to, but 4/3 does not divide evenly. It's going to be a repeating decimal. So I'm going to say approximately 1.3333. Now for number 3, now let's see if you've got tangent J and tangent K correct. So first let's look at tangent J. I have tangent J, opposite over adjacent, and it came out to be approximately 0.5333. Switch that reference angle to K. I did opposite over adjacent, and this one equals 1.8750. Now, I need you to know that 1 through 3, those are all dealing with tangent ratios. Now, moving on, we are finding now a leg length. Now, I need you to kind of stop and pause and look at this problem. It says find the value of x. Well, you think, will the Pythagorean theorem work? No, because this only gives me one side. You think, does the special right triangles work? No, this is a 31-degree angle. So this isn't a case where you have to rely on a trigonomic ratio to find that. You are given an angle and a side. Now, why will we use tangent on this? Well, if you will look, you are given the leg opposite of 17 and the adjacent one. You are not given the hypotenuse on this problem. So since this is our first problem on finding a leg length, we are going to write out detailed steps. So we're going to write steps down so you will have a reference on how to do this. Steps. 1, you are going to write the ratio for tangent of 31 degrees. So you're going to write the ratio for tangent of 31 degrees. So you will say tangent 31 degrees, because 31 is now our reference angle, is equal to the opposite leg, 17, over the adjacent leg, x. That is step 1. Step 2, you will now solve for x. You will solve for x. Now, if you look at this problem, hopefully you can see you are actually given this little cross multiplication problem. So when I ask you to solve for x, I'm actually just asking you to cross multiply and solve the proportion. Now, I'm going to show work on this because I need you to know what we are doing. So if we cross multiply, I am going to first multiply this by x, so x times tangent 31 degrees, and then 1 times 17 will give me this. Now I am asking you to solve this for x. So how would we solve this for x? Well, we are going to divide this side by tangent 31 degrees. If I do it to this side, I have to do it to the other side. So that is 17 divided by tangent 31. Now what makes this solve for x? Well, the ratio that makes tangent 31 is going to cancel out. So step 3, this is a very important step. You are going to use your calculator to solve. Now, you must be in degree mode because this is in degrees. So I do not want you to miss this step. You've got to be in degree mode because that is in degrees. So I'm going to get my calculator. You can see right there I am in degree mode, but I'm going to make sure you understand this is in degree mode. Now, you really need a good calculator to do this, so make sure you are having a calculator that will perform order of operations. So this says x equals 17 divided by tangent 31 degrees. So 17 divided by tangent 31 degrees. Now, that came out to be 28.292 . Now, if you recall, it told us to round the legs to the 10th place. So that is going to be the last step. Step 4. Simplify. Simplify. And for this, we are going to always do tenths for legs. So x is approximately 28.3. We do not have units, so it's just 28.3. So what if you do not have a good calculator? Remember yesterday I showed you that we have a chart. So basically what we just did is, remember we had tangent 31 degrees here. This is tangent 31 degrees. Basically what we just did, the calculator did the work for us, but we did 17 divided by this ratio. Now, the reason why they want this in 10,000ths place is because they don't want a lot of rounding. So if you notice, this is exact, this is rounded, but we still get 28.3 if we use proper rounding rules. Now, the next problem that we are going to attempt to do, you're actually going to attempt this one by yourself. This is question 5.